So we had the cardia, the fundus, the body has the folds to expand, and they are the speed bumps. Kids, what are speed bumps designed for besides slow us down? What are speed bumps like designed to do besides slow us down? They're probably usually in places where there's like schools or something, right? So what is it supposed to do besides slow you down? Probably like not to hit the children, right? That's what okay. Some kids see a speed bump and they like speed up, then they, bottom out on their cars. But like these are what the folds do. The folds are supposed to be to help us slow down the food and help us expand the stomach. Okay, I don't know where my stomach went. Okay, so like inside my model, I have all these folds. The folds help us slow the food down and expand the size of the stomach to a 75 times the size. Okay, so we can do all those things. Then, just like the Fremd parking lot, it funnels into one lane, okay, and really slows us down, okay, and then we have to, takes us 30 minutes to get to class first period because we arrived too late, and they're funneling us into one lane, and then the parents are trying to drop off too, and they're, oh my gosh, does anyone have problems with the Fremd parking lot like me? It's terrible, okay? Well, if you do have the privilege of having a parking pass, you are trying to funnel into the Fremd parking lot, and it just slows down. It's slow. Everyone's getting in car accidents, okay? In the stomach, you want it to be slow. You want it to funnel into the duodenum, which is the first part of the small intestine, very slow, okay? So this is going to be like the cop that stands in Quinton Road that's directing traffic, okay? The pyloric sphincter or the pylorus is going to be making sure it goes car by car. No one's cutting anyone off. No one's, trying to like sneak in a way they shouldn't, okay? That's what the pyloric sphincter is, a doorway. Doorway number 3 that we've now learned. Here, this is the doorway into the duodenum, okay? That we are really controlling the speed of the food to make sure that it's low and slow. Questions for me? Okay. So the other parts we kind of already covered. The pyloric antrum is the wide part of the funnel. So kids, the pyloric antrum is like Quinton Road, right? We're starting to funnel. And then once we turn into the Fremd parking lot, now we're at the canal. It's the narrow end of the funnel. And then the cop that is directing the traffic, trying to go into the parking lot, is going to be the pyloric sphincter. Okay, that's how you're going to remember stuff. Then we have the greater and lesser curvature. So the greater curvature is going to be the bottom of the stomach, and the lesser curvature is going to be like in the middle or medial, okay? That's how I like to describe this, is the stomach is anatomical left, okay, on your anatomical left region. So the part that's most medial to the spine is going to be the lesser curvature, and the greater curvature is going to be part of the stomach that's going to be more lateral, okay, and inferior. So however you want to remember it, that's fine, okay? Total emptying time, 2 to 4 hours to empty the stomach. Carbs empty faster, proteins medium, and lipids are going to be the slowest. Okay, 6 hours they take to empty. Total time of digestion from mouth to anus is 24 to 72 hours. So of those, that time increment, the 2 to 4 hours is just for the stomach alone, okay? Which is why they say, if you're gonna eat something, don't go do some vigorous activity, because this process takes time and you don't wanna be going the other way with your food, okay? Stomach has some special features I gotta talk about today. Number 1, it's got an extra layer of muscle. So we already know we have 2 layers, the circular and longitudinal muscles, right? Here is the picture to prove it. Right here is like where the muscle layers are typically at. We have this extra special layer I want you to highlight. It's called the oblique layer. This gives it its churning properties. Okay, this right here, this extra layer in the stomach. So this column of whatever this is the stomach wall. We've learned about all the layers already in the alimentary canal, but the special layer is that nice muscle layer to help churn and mechanically digest the food, okay? The mucosa layers are different than the normal alimentary canal, okay? So like the top part here, the mucosa, this is strange in the stomach. Okay, we got to talk about it. So this region is going to be here, this, zoomed in. Your stomach, if you were going to go ahead and open it up, which you're going to open up the fetal pig stomach, okay, don't forget. You're going to see the folds in the fetal pig stomach and the cat at the end of the year. I'm going to let you take it out, cut it at the sphincters, and take it out and look at it. Open it up and see what's inside. Your fetal pig might have ate some stuff before it, perished. So, okay, it's not going to be like eating flies or things because it's fetal, which means it died in the pregnant mom, okay? But there might be food in there that the mom provided it somehow, okay? My point to you is that when you open it, the adult cat's going to be even better because that actually lived a life that's outside the womb. Anyways, when you open it up, you're going to see some stuff, some undigested stuff, okay? But you're going to also see these folds, and you might not see these because these are microscopic, but they're going to be like little holes, okay? The holes lead to the pits. The pits, yes. A pit is something that look under, or you look into the soil or something, and it's like a really, really long, dark, tube or tunnel, okay, that leads to nowhere. So that is what your stomach is made of, these pit things, okay? The top part is called the pit. The bottom part is called the gland because it produces something. So this is one whole thing, and then there's more, okay? So this is what it looks like. At the surface, it just looks like these dots, okay? But let's go deep dive a little bit further into the bottom part of the pits. We call the glands, okay? The glands have all these weird cells. The cells are chief cells, okay? Just like my alma mater, U of I, the original mascot was the chief. The chief cells make the protein eaters, okay? Let's write that down. The chief cells make the protein eaters. Always think about this, kids. When I was at U of I liked chicken nuggies. And there was a spot at the corner of Green Street and 4th that sold the chicken nuggies. Okay, what is chicken nuggies? They're proteins. Okay, so the chief, my alma mater, is the chief. It's the Illini now, but it was the chief mascot. Think of the chief cells that make the protein eaters. Okay, that is the enzyme called pepsinogen. So it's going to be up here. Okay. Parietal cells, right above it, they make the acid. And why does it make sense that some of these cells in the stomach make the acid, HCl? It makes a lot of sense, right? That was rhetorical. So stomach acid is made by the parietal cells, these weird, strange blue bulbs. The chief cells make the protein eaters, okay? So these two cells are very close together in the pits. So we're going to make the enzyme, the protein eaters, and then we're going to make the acid right next to it, and that is how you're going to digest your proteins, okay? Kids, look at this here. This is very important. You're paying attention. The problem is that my protein eater is inactive. Do you see the last part of the word pepsinogen? What does that remind you of from yesterday? What is the word when I have something that's active, inactive in one place and then active somewhere else? What's that called? A zymogen. Good. See behind on the board. You see the word zymogen over there? So it's the same thing. Same thing. The ogen part makes whatever the word is inactive. Okay? So go ahead and highlight on your notability the ogen part. The ogen part means that the protein eater, that's what the protein eater is inactive. Okay? So it's gotta be in the right environment in order to be active. Well, it's lucky that right next to it is the right environment, the acid. Okay? So at the very bottom, okay, the protein eater is made. Here it is. Chief cells make pepsinogen. That is the inactive protein eater. And then it floats up, one cell next to it. Then it's ready. Okay, the acid is made. So here's this chemical formula thing. We are converting pepsinogen to pepsin. Now it's active. Okay, so the acid that's made, here it is. Here's the acid that is made by the parietal cell right next door is going to activate my protein eater. So we are going to take our knife, whatever you want to do, knife. You are going to cut off the ogen part. We're cutting it off. Pew, pew. And now it's active. Pepsin is go time. Go time. Eat proteins. Eat those proteins. Okay? So pepsin means it's the protein eater and it's active. If you have the ogen part, it's like inactive. Like you're muffling it. Like it's muzzled. Okay? Don't eat yet. So that is what's happening in the pits of your stomach, okay? It's got to be carefully regulated. Think about this, okay? Let's think philosophically, okay, for a second. What is your hair made out of? Go. Yeah, protein. Protein. Your hair is made out of protein. What is this made out of? Protein. Anything that's muscles or meats or organs is made out of protein. So, it would be not wise to have a protein eater on the loose, right? So you need to have it carefully regulated. It has to be right next door in these pits in order to eat the protein that you consume. And it takes a long time to eat them because it's carefully regulated. If you had this just out and about, if this was not a zymogen, you would be eating yourself from the inside. Because you are made of protein, your whole body. So, isn't it kind of strange that we eat protein and we're also made of it? Well, we're also made of other things like carbs and fats. But like protein is our predominant structure in the body. So we need to make sure it's carefully regulated, okay? Or else we're going to let the beast out, okay? And then it's going to eat everything. That would be like the perfect biological warfare. It's just like a protein eater because it would eat all things on this planet, okay? So it's carefully regulated. It's right next door. So the chief cell makes the inactive protein eaters. They float up. They hit the acid that's here from the parietal cell, okay? And then as they float up, they get hit with the mucus and they get neutralized like this, okay? And then the protein eater is deactivated again. It's crazy, okay? So all that is just trying to tell you that we need to be careful, okay? So chief cells, they make pepsinogen, which is the inactive form of pepsin, which digests proteins, another enzyme for our giant list. Okay. And then it also makes gastric lipase to help with digestion of lipids. So another enzyme. But this one does not say lingual lipase. This one says gastric lipase. So the word in front is where it's made. Gastric lipase, made in the stomach, works in the stomach too, not a zymogen. Okay. Parietal cells are the ones that make the acid. So they maintain the pH between 1.5 and 3.5. And they activate pepsinogen to pepsin. They also make this thing called intrinsic factor, which is kind of random, not having to do with pepsinogen or lipid digestion at all. It helps stimulate your small intestine to absorb folate. So folate is that special vitamin that helps us have good neural formation and function and develop our red blood cells. Okay? So two cells I've talked about, they're right next to each other. On this picture, it's like that bluish, like here, and parietal cells are right next door. There are some G cells at the bottom. They help stimulate hormone gastrin, hormone, not an enzyme, which helps stimulate acid secretion, okay? And they promote emptying the stomach. So you can just go like this, G cells, and you can just point to here. I don't really care how you do it. Lastly, we have mucus cells, also known as goblet cells. We've already learned. But the problem is that kids get cells and goblet cells confused. So then I just say mucus cells, okay? Because you see how they both sound with G. Okay, so G cells secrete a hormone gastrin, and goblet mucus cells secrete alkaline mucus. Alkaline means basic. So it helps neutralize your stomach lining. Okay, because you have all this acid, and you need to neutralize it when it's starting to leave the stomach. Okay, so we need to have this mucus kind of neutralize things. Okay, it protects your stomach lining. So the barrier, it's just more of this. Mucosal barrier helps protect and it provides a physical barrier to all of the acid that's hitting it, okay? So here's the picture that kind of shows this. You see the stomach cells, okay? You see that it's a pH of 2 in the lumen of the stomach. So we have these bicarbonate ions that are basic that will help neutralize the pH of 2. So if I say this is a pH of 13, okay, 2 plus 13 divided by 2 is somewhat neutral, okay? So this is how the surface is maintained at pH of 7. We got a pH of 2, pH of 13, kind of slap those together, mix them up, we get about a neutral pH, okay? This is right, neutralize here. So the bicarbonate ions neutralize the acid. The cells are tightly packed, so no gastric juice leaks. Any damaged cells are quickly replaced. The replacement rate is at about 3 to 6 days. You get new epithelial tissue in your digestive tract, and it just it comes out with your feces. So this table at the bottom is a review of the different ways that the stomach digests in the body. Mechanical means the physical movement. So the mixing waves, it begins the moment the food enters the cardia. Okay. The waves start at the body of the stomach and increase in intensity as they reach the pylorus, as we reach the Frem parking lot 1 lane, okay? It mixes the food with gastric juices, creating that soupy chyme, and the initial waves are gentle, but they become much more intense, okay? Then your stomach empties at about 3 milliliters of chyme at a time through the pyloric sphincter into the duodenum. So that's like kind of like how slow it goes. But it just kind of squirts out of your stomach into the small intestine. That's like kind of like what it looks like. Okay. Chemically, your food sits in the upper fundus for a while, and then it drops into the body of the stomach, making chyme. Salivary amylase still continues to work on those carbohydrates until it drops into the acid and becomes denatured. The food mixes with the chyme, and salivary amylase deactivates. Lingual lipase activates, and gastric lipase is also made and activates. Pepsin and HCl will begin their chemical digestion of proteins in this area as well. Okay, all things you should be adding to your list. And my friends, this bottom table is all the different enzymes, where they're made, where they work in one thing, but I think this table's a little confusing, so you don't really have to go through that. Okay.